Hello guys, welcome to my YouTube channel. In this video I am going to complete the part 3 of this OHR modeling. In last video we have modeled the OHR up to the top dome slab. So in this video I am going to cover how to model this beam and column for this stair, and also I am going to model this walkway. So this video is going to very interesting video, so please watch the full video. And if you are new in my channel, please subscribe my channel to get this type of video in future. And also I have started many different type of videos, so if you are interested you can watch them in my channel. So let's begin. As you can see here, the stair is a steel stair, so that's why we don't need to model this stair in our model. So that's why what I am going to do, I am just going to consider the load of this steel stair. So there are many ways you can consider the steel stair load here. Either you can consider the load at each node, or you can consider the steel stair load as a vertical UDL on this column. So obviously if you consider the stair load as a vertical UDL for this column, that will be more accurate method to consider the load of this stair. So that's why I'm going to apply a vertical UDL on this column to consider the stair load here. So that part I will show when I will apply load on this structure. So now currently just I'm going to model these beams and column in our structure. So to model that, you need to know the column center position. Here you can see the distance is given of this column center. Here along x-axis this distance is 6.517, and along z-axis this distance is 3.763. Now I am going to create that node in foundation level. Here you can see the foundation level at y equal to 0 meter. So now I'm just going to create that node here. To create that node, click on this geometry tab and then go to the last row in this node table, and here write the coordinate. So along x-axis this distance will be 6.517, and along z-axis this distance will be minus 3.763. so I'm going to write here this. Here it will be 6.517, and this value should be 0, and along z-axis this will be minus 3.763. So as you can see here, the node is created. Now I am going to repeat this node in y direction at 2.5 meter 1 times, and at 4.6 meter 3 times, and at 1.7 meter 1 times, and then 4.8 meter 1 times. Just select this node and click on this translation repeat tab, and here select global direction y, and here it will be total step will be 6, and default steps spacing I am going to write 4.6, and here the first spacing will be 2.5, and second, third and fourth will be 4.6, then fifth will be 1.7, and last one will be 4.8. and here I am going to turn on this link step and just click on this OK tab, and here you can see the column is created. Now we are going to model this tie beam or basing beam in our STAAD model. So here you can see this tie beam you have to provide at this tie level, and also here and here and here. So you need to provide this bracing beam at 4 different level. The distance between these two level is 4.6, and up to here this distance is same, which is 4.6. So it's very simple to add this beam in STAAD Pro model. So first you need to draw two beams here, and now I'm going to draw here two beams. To draw two beams here like these two beams, just you need to use this add beam command, or you can access this command from here, from geometry to add beam, then click on this add beam from point to point. Using this command, I'm going to draw these two beams here. Now our two beam is created, and now just select these two beam using beam cursor, and now I'm just going to repeat these two beams up to 3 times, and the spacing of this step will be 4.6. so just click on this translation repeat, and here the global direction should be y, and here the number steps would be 3, and this should be 4.6. and now just click on this OK tab, and here you can see the beam is created at different level. And now we need to provide the property of this beam, and here you can see the properties given of this beam, that is 250 by 300, or 250 is the width and 300 is the depth. I'm just going to select the missing property here, so just click on this select, and here click on this by missing attribute and select here missing property, and here you can see the missing property beam is selected. And now I'm going to click on this view and just going to click on this view selected object only, and here only we can see the missing property object. And now first I'm going to provide the property for this basing beam. So just I want to select the basing beam. There are many ways you can select, so I'm going to follow here. First I'm going to select the beams parallel to y, then I'm going to inverse it. So now here you can see the basing beams only selected here, and now I'm going to assign the property. To assign the property, you need to go to this property page, and here the dimension will be 250 by 300. So just click on this define tab and select here rectangle, and here provide the depth is 0.3 and width will be 0.25. Now just assign, and here you can see the bracing beam property is assigned. And now we need to assign the property for this column member. So just select the beam parallel to y, and here you can see the column member is selected. Here the dimension of this column is not given, say as here you can see the foundation size is 500, so I am considering the dimension of this column is 250, and it is a circular column. So now I'm just going to provide it here. So just going to click on this define, and now here diameter, which is 250, and now I'm going to assign it. So now I have assigned the section properties for this column section. To remove this section property mark from this object, you need to press Shift plus X, and now here you can see our model is ready for stair load consideration. You need to model here this platform here, and here you can see the platform width is given, which is 1000 millimeter. So you need to model this platform here. To model this platform, first you need to define a grid, suitable grid. So before that, we need to study the drawing here. Here you can see this distance from the face of this wall is 1 meter, but as we are doing here center line modeling, so it's mean from the center of this wall this distance will be 1.125, and also when we have created this wall we have used 6.125 is the radius, not only 6. That's why what you need to do, you need to create this platform that start radius should be 6.125 and the end radius will be 7.125. To model this platform in STAAD software, you need to define the grid first. You cannot model this platform using structural wizard, so that's why you need to define the grid here. To define grid, just click on this snap node beam button, and here you can see I have already created one G1 radial grid here. So using that grid you can create here the plate at this platform, but first I'm going to show you how can you create this grid. Now if we see the radius of this cylindrical wall, that is 6.125. so just I have told you I have used center line modeling, so that's why it is 6.125. and now our start radius will be 6.125. you have to know at which level you need to create this grid, so you need to know the y coordinate also. So this is the level. At this level I want to create the platform, so here the y is 18 meter. So this thing you also need to know. So now just I'm going to create this grid here. So click on this create button, and here first select it is radial. As you know, here we need to define radial grid as the shape is circular, and suppose I'm naming this grid as G2, and here the plane should be XZ. So as you can see, if you go in the top view, here all the structure I can see at XZ, and our platform should be at XZ plane, so that's why this plane should be XZ. And here the grid origin X and Z will be 0, but Y should be 18 meter. Okay, and here the start angle will be 0 and sweep will be 360 degree, and here the number of bays should be matched with the division of this circular shape wall. Otherwise what will happen when you will create the plate at this node, that there will be an plate connectivity issue. So that's why you need to keep this number of divisions same as the number of division of this circular plate. So that's why it is 24. So in our case I have used 24 divisions, so that's why it is 24. And here the start radius should be 6.125 as I have discussed, and the end radius will be 7.125. and now I'm just going to click on this OK button, and here you can see the G2 radial grid is created. So just click on it, and here you can see the division, the grid is created. But here one thing you need to verify, you need to change. Just I'm going to edit this. So here edit option is not available. Just open this grid option again, this will be available here. And now here this division along the radial direction, the division I am keeping it 3. Okay, otherwise you know there may come some badly saved plate error may come, so that's why I'm making it 3. Just click on this OK, and now here you can see the grid is visible at this level. So our grid is totally ready. By using this grid we can easily model this platform. So to model the platform, you need to draw the plate at this platform level manually. So that's why you need some nodes here. So by using this snap node beam option, I'm just going to create some node here. Just click on each grid node, automatically node and beam will be created, as you can see. So here I'm just creating some nodes to draw the plate member. Click on this beam cursor, and I'm just going to delete these beams. These beams are not required actually. Just I have draw on this beam only for to get this node. Just I'm deleting this. And here if you click on this yes option, what will happen, this node also will be deleted, but I don't want to delete those nodes. I'm just clicking on this no option. So here you can see the nodes are there. By using this option at 4 node plates, I can create the plate member here. But here one question you may face, what will be the plate orientation? I mean, if you start the plate like this, that time its plate orientation will be different, and if you start the plate like this, that time its plate orientation will be different. So you need to know what will be the correct plate orientation for this plate member. So how can you know that? To know plate orientation, just press Shift plus T option to see the plate orientation. So here you can see the plate orientation for all these plate. So what I will do, just I will select one plate from top bottom slab. Say I'm selecting this plate. So before that you need to click on this plate cursor and now select this, and just I'm right click on it, and here you can see the new view option. Click on it, and here select create a new window for the view, then click on OK, and here in new window you can see only this one plate, and just go to on the top view, and here you can see the plate orientation. So here Y is along the radial direction and X is along the circumferential direction. The orientation for all top dome slab plate is like this. It's mean the y-axis, the local y-axis is along radial direction and local x-axis is along circumferential direction, and also z is perpendicular to this. So now whatever plate we will create here, that should be the same orientation. So this plate I have just created few minutes ago. So here the x-axis along the radial direction, but in our top dome slab all the plate orientation like that, the x-axis along circumferential direction. So this plate orientation it's not matching with that, so that's why I'm just going to delete this plate. I'm going to draw it again. So just select it and press delete from keyboard, and here it is asking that all the orphan node you want to delete or not. So I am just click on no, because I need this node. Just click on this add 4 nodes plate command, and now here our first x-axis will be along circumferential direction, so that's why this will be the x-axis and this will be the y-axis. So like this you need to draw the plate, and here you can see this is the x-axis direction, this is the y-axis, and perpendicular in upward direction, that is the z-axis. So here this orientation is very important, because if you mix the plate orientation, what will happen when you will get the moment result from STAAD output, you cannot distinguish these two different moment. I mean, there is one moment that is along radial direction and there is another moment that is along circumferential direction. So if your plate orientation is not correct, what will happen, this all moment will mix up and you cannot distinguish them. So that time you have to provide the same reinforcement in both directions, so that time the structure will may not be economical. So that's why the modeling is very important. When you are modeling this type of structure where the plates member are involved, you need to be sure that the plate orientation same for all members. Otherwise what will happen, there you cannot distinguish them. So that's why just I'm creating the plate orientation same here like this, and now I'm going to draw another plate here like this and another plate here like this. So now I have just created 3 plate here, and these 3 plate I can repeat in circular direction. So just I'm going to do this. Just select this 3 plate here and then go to circular repeat, and here this will be number of steps would be 24, because you know when I have created this grid my division was 24, so that's why it should be 24. And just click on this OK option, and here you can see this plate is created. So let's see it in 3D render view so that you can understand. And here you can see this platform is created. So it's very easy. Now here just you have to write the thickness. So here you can see the thickness is given, which is 125 mm. So just I'm going to select this plate. So go to select option and click on by missing attribute, and here select missing property, and here you can see this newly created plate is selected. And now just click on this property assignment page, and here define another thickness, that is 0.125 meter, and click on assign. And now here the plate property is assigned. And now I want to just create another group for this plate member. So just press Ctrl G and click on create, and name this group as a platform, and this should be plate, this group type, and click on OK and just associate it. Here you can see this plate are associated with this group. Okay, so now one more thing we have to do, that is the support for this column member. Just select this node and go to this support page, and here just assign this support. Select this node again, assign it. So here the support is assigned. So now our model is totally ready for loading. Each and every part I have modeled in your structure, so that we can easily apply the load on all this component. So if this video is very helpful for you, please like this video, subscribe my channel and share it to others. So I have a like target, so if you guys keep 20 like in this video, I'll make part 4 on this topic, where I will show how can you apply the load on this type of structure as per IS code. So please stay tuned with us. Very soon I'm going to publish more interesting video on this design topic. Thank you for watching.